Hi guys, welcome back. In this video we are going to look at creating a graph of our means to compare the three means between the three treatments. So first off we need to make a graph, so we will highlight and we're going to go insert recommended charts, or you can just do here, and it's just a basic column graph. You'll notice that this has 1, 2, 3 down the bottom. I'm pretty sure if you right click select data, it'll allow you to edit just like we've done before and highlight and OK. So I just edited it here. So for 1, 2, 3, I've got that. Okay, I'm going to delete my title. I don't need it because I'm going to add a figure label later. Okay, our figure labels go down the bottom of our graphs when we put it into our actual report. That'll be very clear when we do our report. I'm also going to add some axes labels, so axes titles. So up here, this is the, I'm not sure, the number of possums, and this is the treatment. Pretty sure that will do for our titles. Now we've got a beautiful bar graph here, and we've got the means showing urban well lit, urban poorly lit, non-urban. You can see it gets bigger. But on our graph, because we want to look at our accuracy on our graph, we're actually going to add in what we call error bars. So we're going to go add element, error bars. Okay, now the automatic error bars, they don't tell you anything. I'm just going to click on it anyway and then get my options up. We want standard error, but we want to use the standard error that we calculated. So Excel is not using our original data to calculate that standard error. It's just using your mean. So it has no idea what the actual standard error is because we didn't highlight our normal data. We're just doing the means. So we're going to have to actually go more options and put in our standard error. So just double check. You might have accidentally got to the wrong tab here. I sometimes do that. Make sure you go to this tab up here. And then we're going to make sure we've got both. We want plus and minus because standard error is plus and minus. And we're doing custom. Okay. So standard error is just over here. So we're going to specify the values. It's off my screen a little bit. I'll have to scroll across. I want 1, 2, 3 for the positive. And I also want the same for the negative as well. So I'll do that as well because we want plus and minus for all three. Okay, let's have a look. Alright, now we've got a little bit of a difference here. So this has a small standard error, a larger standard error, and that's reflected in our numbers here as well. We've got 1.7 and 8.5. So now we've got a bit of a better image of what these look like. Let's have a chat about standard error bars. Now I'm going to jump over to my OneNote, and I've already scribbled on this one. So actually I'm going to make a new little spot down here where I can talk about it without scribbling on it. So here's an example of a graph. You don't need to know what it's for. It's just an example of a standard error graph. Now when we're looking at this one, so I'm just going to grab my pen. The error bars mean that we are not sure where this mean lies. Okay, so we're not sure how close we are to that target in the middle. Okay, so where that mean actually is. Now this one has a large amount of error, so that mean could be all the way up here or all the way down here. We just don't know. Okay, we're super uncertain about this actually. So if they overlap, if these error bars overlap, and by overlap I mean that this error bar shares an area with the other one. Can you see how they're sort of overlapping here? Okay, compared to maybe, say this is A and this is B, compared to B and C, which don't actually overlap. If I extend the error bar caps across, you see how C and B don't overlap, but B and A do. Okay, that means that these two means could actually be the same. We don't know if they're actually different or not. We're really uncertain about them. But these two, because this one is so certain, even though this one's a little bit uncertain, we know that they have to be different because this one won't fall outside those error bars, we're pretty sure. Okay, now, more likely you're going to get something, maybe it's not a huge error, you might have big error, something like this. okay, where you've got a little bit of overlap, okay? It doesn't necessarily mean that they're the same, but it suggests that they could be, okay? So it suggests there might not be a statistical significance or statistical difference is what I'm trying to say. Okay, so if the error bars overlap, we might not have a statistical difference. So let's go back to our error bars and have a look at them. Okay, number 1 and number 2, do they overlap? No. Okay, so we are assuming that that means that they are different. Number 2 and number 3, so urban polylit and non-urban, there is definitely some overlap here. Can you see that? Now number 1 and number 3, I don't see much overlap there at all. Okay, interesting. Right, so let's double triple check this by running a t-test. Now we're going to have to do a 3-prong t-test. I just might do, I'll put this out of the way. Ooh. Let me grab the whole thing, put it out of the way. I'm going to actually keep that because I'm going to put that in my report later. I'm going to do a t-test now. So to do a t-test, remember I'm choosing a t-test because I want to know, is there a statistical difference? Okay, the t-test I'm going to use, sorry, this is jumping all over the place. The t-test I'm going to use is, I'm going to highlight this, although I probably don't need to because it's going to make me highlight again. Data analysis is the 2 sample assuming unequal variance. The reason why I'm not doing paired is because they don't match up exactly. So you're probably going to be using this t-test down here, the third t-test in my options. It's unlikely we have equal variance in biology because it is biology, so you often get a lot of variance and different variances. So we're actually going to use the third one here, okay? Okay, and the samples are not paired in this example. So let's do highlight this one. Okay, and let's see if there's actually a difference between urban well lit and non-urban. So let's do that one first. Just because I'm curious, because there is such a difference. I've got labels in mind. You might not have highlighted your labels. Just click on or off if you've actually included the top line or not. And now alpha 0.05, that should be your standard. The alpha is predetermined, and in science we usually go with 0.05. It is the level of significance that we deemed is an appropriate amount. So essentially, it sort of means like there's a 5% chance that these are the same. When we say if there's a 5% chance, we're 95% confident they're different. So that's our sort of level. So if it's below this number, we say they're statistically different. If it's above this number or equal to 0.05, we can't say that it's statistically different. Talk about that in a second when we analyze our data. I'm going to put output range just on my worksheet, maybe down here. Oh, is it going to let me? Excuse me. I'm just going to put it down there, right underneath. You can do a new worksheet, new workbook, but I've already got heaps of sheets because I've been doing that today. So let's go. Okay. Output range overlays existing data. Okay, yeah, that's fine. Oh yeah, I've already done some data down here. That's okay. I'm going to delete all of that. So we get this little thing, all right? So that's our test that we did. Here's our means. And we go down to, now, if we had a preconceived idea of there being a difference, we'd use a one-tail, okay? So in yours, if you're expecting a certain concentration or temperature to have a certain difference, use one-tail. If you're just looking for any difference, use a two-tail, okay? So for this one, I am going to use a two-tail. For your one, you might have to use a one-tail because if you're saying a certain concentration or whatever you have is going to be higher than another one, it's going to have a shorter reaction time than another, then you might need to use a one-tail. Okie dokie. So I'm just going to highlight this. All right, that's my p-value two-tail. Okay. So my p-value is less than 0.05. So therefore, that is statistically different, which is supported by my error bars not overlapping. Okay. Now I've done this for all the other ones, so I went, okay, I've done those two. I'm gonna have to go through and do urban well lit compared to urban poorly lit for a t-test, comparing those two, and I'm gonna compare these two as well. Do the same process as we just did before. If you're doing 3 different concentrations, for example, you will need to go through and do the 3. If you're just doing 2, 2 is fine. Okay. Here's what I said about it. As there are no error overlap in the error bars, which are standard error, I have to say that because otherwise error bars don't make sense, in figure 1, and I'm going to have a label up underneath my figure so I know which one's figure 1, it indicates that there is a statistical difference between the 2 means of urban well lit and the other 2 treatments. Okay, sounds good so far. This is confirmed with the two-tail t-test, which shows a p-value of 1.7 times by 10 to the negative 5. Now, when that came out, it looked like 1.7 negative 0.5, something like that. You get a funny number, and it probably has a lot more numbers. That E is just times by, it's scientific units. So you just turn it into a times by 10 to the negative 0.05. So really what that is actually saying, it's like 0.1234 517, something like that. So definitely lower than 0.05. And then the other one was the one we just did. Okay. Which are both below the agreed level of significance. I should have put respectively, so I know which one's which. Both the agreed level of significance, which we have already predetermined is the alpha 0.05. Okay, so therefore they're definitely, well, not definitely, there's nothing absolutely certain in science, but they are statistically different. Statistical difference. However, there is no statistical difference between urban poorly lit and non-urban treatment. So let's go back up. Let's have a look at our graph. Urban poorly lit and non-urban. Yeah, you can see that overlap. And I did a t-test between the two to prove it. No statistical difference in urban poorly lit and non-urban treatments. As their t-test, p-value is 0.03. This is supported by the overlap in error bars on figure 1. And I've already said the error bars are standard error, so I don't need to repeat myself. Okay, so that's how you do your graph, that's how you do your t-tests, and that's how you interpret it. Like, comment, and subscribe. Bye.